is here time is the independent variable, right? Time is the independent variable and velocity is the dependent one. So why this means? Let me look at is my screen visible to you guys? Yes. Is the screen visible to you guys? So what I was talking that whenever okay, so instantaneous acceleration is what? This is simply differentiation of velocity with respect to time, right? And we also know that what is this instantaneous velocity? So instantaneous velocity is dx by dt, right? So when we place the v value of v in here, so we'll get what? D by dt of dx by dt. So we have one differentiation and then on top of that we have another differentiation. So we can write this as d square x by dt square. Right. So this is called the second order differentiation. So then I say that if in question, right? So if in the question they have given you some form of v, right? Let's say 3t square plus 4t plus 5. So this in this question form of velocity is given, right? Then you can calculate the instantaneous acceleration, right? Or let's say that if they have given you the form of x, form of distance, so let's say t 65 plus 4t square plus t, right? So this is given. So then how do you calculate instantaneous acceleration? So you differentiate this x two times, right? So this would be t square by dt square. So let us take some example and then understand. Okay, so let us take this example, right? So in this question, we are given the form of velocity, right? So v is dt square plus 4t plus 5, right? And then we need to find out what is acceleration from 0 to 5. 5 would be 5 seconds, and the second question would be that what is the acceleration at t equal to 2. So, Elham, you tell me that this is what kind of acceleration? Yeah, this is what kind of acceleration? Yes. Did you understand the question?
Sorry, sir.
Yeah. So in this question, they are asking us to calculate the acceleration from 0 to 5 seconds, right? So
Yes.
what kind of acceleration we will calculate? We have two kinds of acceleration: average and then the instantaneous. So in this part, what acceleration we will calculate?
So instantaneous.
Okay, so for instantaneous one, they ask about the acceleration at a particular time.
Yes, sir.
But in this question, they are asking us to calculate the acceleration from 0 to 5 seconds. Right, so this is about a journey from 0 to 5 seconds.
Yes, sir.
So what acceleration we will calculate?
So average.
Average acceleration. Yes. So yeah, guys, did you understand this part? Yes. Rishita, Akib, Afaf, Amna, understood.
Yes, sir.
Okay. So Amna, you tell me what is the average acceleration? Why this cursor? Yeah, Amna, you tell me what is the average acceleration, or you have forgotten? Yes, average acceleration.
Delta V
Yes, yes,
by delta T.
yes. So delta V by delta T, right? Which is
Yes,
V final minus V initial divided by T final minus T, right?
yes,
So V final is what? V at 5 seconds,
5 seconds,
and V initial is V at
3
0,
seconds.
and T final is 5 minus 0, right?
Yes,
So what is V at 5? We know V. So V at 5 is, this is the first question, right? And V at 5 is what? 3 into 5 square plus 4 into 5 plus 5. So this would be 75 plus 20 plus 5. So 25, 75, 100. So this is that. And what is V0? What is V0, guys? V0 would be, yeah, my internet, maybe there's a problem with this. 0 would be 3, 0 square plus 4, 0 plus 5. So this is 0, this is 0, so only 5. Right, now we have calculated V5, now we have calculated V0. So just plug in these values. So average acceleration would be how much? Let us, write that A average. This would be 100 minus 5 by 5. So this will be 95 by 5, which is 1. So 19, and let's say units are, this is meter per second. That's meter per second. Any doubt in this problem, guys? Any doubt? Yeah. Any doubt? Yes, guys. Do you guys have any doubt? Okay. So now let us solve the second problem. Instantaneous activation. So A.
Sir, we have to write this.
Yeah.
We have to write this.
Yeah. Please note it down. Right. Please note it down. Yeah. Note it down, and then we do the second part. So whenever you guys have completed a meeting, guys, please. Yes, noted, guys.
Yes, sir. Yes, sir.
Okay, now instantaneous access. So in the second, oh, I already told the answer. So in the second question, they ask about. So you see that in the second question, they ask about what is the acceleration at t equals to 2 seconds. So at a particular instant, they want us to calculate the acceleration, right? So that would be what acceleration? Yeah. So that would be instantaneous acceleration, right, guys? So that would be instantaneous acceleration, and the form of v is given, right? So what we will use here? We will use. Okay, so why that? So, right, right. So v we know. V is what? V is d by dt of dt square plus 4t plus 5. So you guys just calculate this and tell me the answer. So everybody please calculate this and tell me the answer. What would be the differentiation? So you guys quickly calculate and tell me the answer. Yes, who is calculating? Rishida, आंखें बफा Ilham and Amna. Abdul didn't try, right? Yes, what did you guys get? 6t plus 4t. So 60 plus 40 would be 10t, right?
Yes, sir.
Yeah, but so differentiation of t square would be 2t. So this is 6t. Or let me write it properly. Yeah, Afaf is getting 60 plus 40. Rishida, Akib, and
Sir, will it be 6t or 6t square?
yeah, so you are calculating the differentiation. So the power would be one less, right?
Yes.
Yeah. Okay. What are you guys getting? Akib, Rishida, and Anam, Amna. Hmm. What did you guys get? Guys are calculating on 90 plus okay, so Amna got 90 plus and Rishida, Akib, Elham. What did you guys get? Quickly, quickly. So if you guys are stuck, so you guys can just right. The differentiation question. So we did some question based on right. Okay. Not getting. So Akib didn't get the answers. Okay. So and what about Rishida and Ham?
Sir, 1 second.
Yeah. What did you guys get? Hmm. Yeah. What did you guys get? Okay. Ham is also. Okay. So let us uh, so D
Sir, I got 60 plus 4,
60 plus
20.
right 60 plus 4 are stuck. So yeah, please you guys need to write practice. So whether it is wrong or right, don't bother about that. At least try. So d of 3t square by dt plus d by dt of 4t, right? And then
Yes.
d
Plus
by
d by dt 5, which is constant.
so this is it, right? And then okay, my cursor. Okay. So now, oh yeah. So this is the constant term. So this would be outside,
18 and
right?
dt square by dt plus 4 dt by dt.
Right. So dt by dt is one, right? So t
Yes.
square. What would be the differentiation of t square? So two would come in bottom, and then in power you subtract one,
2t. 2
and
minus 1.
so this would be 6t plus 4.
6t plus 4.
So this would be the answer, right? This is the acceleration.
Oh, t on.
Yeah. Yes, Afaf, what do you
Okay.
say? Yes.
No, I said after 40 won't come. 40 won't come. Only
Yes.
4 will come.
So dt by dt is 1, right? Or you can also see this way that what is the power on t? What is the power on t? 1, right?
1.
So
Yes,
1,
1.
1 would come in bottom, and then you subtract 1 from it. So 1t0. This would be how much?
0.
T0 is 1, right? So this would be 1.
Yes.
So this would be 1. So 4 into 1, which is 4. Right.
Yes.
Okay, so we can also write dt by dt is 1. So we can see it that way. Or if t is power 1, so we can solve this way also. So is this clear to you guys?
Yes, it is clear.
So the acceleration is varying like this, right? And in the question,
Sir,
there.
once can you explain the average acceleration? I
Okay,
understood half of it.
okay. So for the average acceleration, what do? Is that you calculate the average acceleration when they ask you about the acceleration throughout the journey, right? So you will be given some form of velocity, and then they will ask you that what is the acceleration from 0 to 5 seconds. So from 0 to 5 seconds, which means that they are asking about some journey, right? From 0 to 5 seconds, from initial time to final time. So this, and so for this, you need to calculate the average acceleration, right? And average acceleration, as we learned in the previous class, that this would be how much? So this would be y. So average acceleration is what? Delta v by delta t, which is v final minus v initial by t final minus t initial. This is the average acceleration, right? So then we just calculate from here why this is okay. So what is the initial time here? Afa. Yeah. Am I audible, guys?
0,
Yeah, 0 and final time is 5. So then
5.
we, yeah, so then we calculate the average acceleration by t final minus p initial by t final minus t initial. So for final velocity, time is 5 seconds. So we calculate the velocity at 5 seconds, right? And then we calculated the initial velocity. So then we have all the values. Then we just plug in the values and then we get the average. Understood?
Yes, sir.
Okay. And now we want to calculate the acceleration at t equals to 2 seconds. So this would be how much? This would be, we have calculated the acceleration for t second. So what is the value of t given in the question? Yeah, what is the value of t given in the question?
Uh,
What
value of
t, right? They are asking us to calculate the acceleration at
2
t,
seconds.
right? So t is 2.
6 liters. 12 plus 12, 16. 6
Yeah,
meters per second square.
yeah. So let me why this is like this. Okay, so why? Okay, there is some problem with it. Yeah, so let me bring the guys. So, okay, so value of as Afaf said, value of t is how much? This is
16.
t equals to 2,
Yes.
right? So I guess my network is right. Uh, yeah, t is equal to 2 seconds. So A2 would be how much? This would be 6 into 2 plus 4. So 12 plus 4, which is 16 meter per second square. So this is the answer when the form of V was given. Okay. Now we will talk about when form of distance is given. So you guys please note it down first, and then we'll talk about the other type. Any doubt in this problem?
No, no, sir.
Yeah, please note it down.
Done, sir.
Then, what about you guys? Rest of you guys, Rishta, Ram, Amna,
Yes, sir.
Yes,
Yes,
sir.
sir.
yeah. Okay. Yes, Akib, are you there? Okay, so now in this question, this is a complete question. So the distance of uh, an object which is moving varies as it, right. So x is let's say 5t cubed plus 4t squared plus 3t and plus 5. Right. So this is given, and the question would be find average velocity at velocity from t equal to what? Let's say 5 0 second to let's say t equal to right. So we have to find the average velocity, and then in the second question we have to find the velocity at uh, at t equal to okay, at t equal to 2. And in the third question, they will ask you that find acceleration from 0 to 3. And lastly, they will tell you that find the acceleration at t equal to 4 seconds. Okay, so these are the 4 questions that you have, right? So in this question, okay, I should write not the average. So you guys should identify that they are asking us to calculate the velocity from t equals to 0 second to t equals to 4 seconds. Right, so this what velocity we will calculate? Yes, what velocity we will calculate, guys?
Average
Average.
velocity.
Yes, absolutely correct. So average velocity. Right, so in this question we will calculate velocity average, and in this question we will calculate what? Instantaneous velocity. In this question we will calculate acceleration average, and in this question we will calculate the instantaneous acceleration. Right, guys?
Yes.
So now let us find the solution. So first is the average velocity from 0 to 4 seconds. What was the form? 5t cubed plus x is 5t cubed plus 4t square plus 3t plus 5. This is right. And to calculate the average velocity, what we will calculate? Rishita, you tell me, how do we calculate the average velocity? Yes. How do we calculate the average velocity? Yes, Rishita. Akib, Afaf. Yes.
So over here,
Yeah. Rishita. How do we calculate the average velocity?
so V into 4 minus V into 0 by 4 minus 0.
No, just remember that we are calculating the average velocity. So this would be delta x by delta t, right? Right.
Yes.
So this would be final x final minus x initial divided by t final minus t initial, right? X, not v, right? Because we are calculating the velocity. Acceleration would be v final minus v initial, right? Just remember this, that velocity is change in distance divided by, this is average velocity, right? And then we have this average acceleration. So this is change in velocity. Right? So don't,
Delta V by delta T.
yeah. So now this would be x, what? X 4 minus of x 0 divided by 4 minus. So x4 would be how much? X4 would be 5, 4 cube. Oh, this is a big number. So 4 square plus 3,
Plus
4.
3 into 4 plus 5.
Yeah, and for 0, this would all be cancelled and we'll have only 5. So
No, 5, 5.
5 cancelled. 5. So this is how 5 into 64 plus 64 plus 12 divided by 4. So this is
320 plus 6.
from 6 and 5 and 2, 7 and 3.
396.
Yeah, so 9 and so 94 meter per second. Right. You guys, please note down this question as well as the first answer.
396, right?
396. Oh, so 61729. Yeah, 96. So this would be how much? So then this will not cancel, and then we have, yeah, so then we'll have what? Okay, so 99. Right. So 99 meter
Yes.
per second. So you guys please note down the question as well as the first answer, and then we'll talk about the second one. Any doubt up to this point? Yes. Please quickly note it down, and then we'll talk about the next second question.
So can you scroll down? Chatter, Mandara.
Yeah. So whenever you guys have noted it, please take. Noted everybody.
Yes, sir.
What about Ishita, Rafa, Akib, Amna?
Yes, sir.
Okay, so now let us do the second problem, right? In the second problem, we need to calculate the velocity at 2 seconds. So that is what? Average velocity or the instantaneous one? Yes, so guys tell me the answer, and yeah.
2 cube plus 4 into 2 cube, 2 square plus 3 into 2 plus 5.
Yeah, so I'm asking about that they want us to calculate the velocity at 2 seconds. So this is what kind
2
of velocity?
seconds.
Instantaneous velocity or the average velocity? We should calculate what?
Velocity.
Instantaneous.
Yeah, instantaneous velocity, right? So V instantaneous, and this is what? This is dx by dt, right? So velocity is change in distance divided by change in time. So then dx is given, and you guys quickly calculate, and everybody try this problem. So 3t square plus 4t plus 3t plus 5. So what would be the that you guys calculate and tell me the answer. Yes, calculate and
10t square plus 4t plus 3.
15t square plus 40
Yes, 40.
plus 3. So this is about. Yes. Rishita, Akif, Ilham, and Amna.
So 15t square plus 8t plus 3.
3t square plus 8t plus 3. This is and what about Akif and Ilham, Amna?
Just a minute, sir.
Yes. Yes, Afaf or Rishita. So guys,
Sir, minus 480, not 40. I did a mistake there.
yeah. So minus of the,
No, plus 80.
yeah. So,
80 plus.
okay, so we have two people who have got the same. So majority is with this answer, right? You guys also calculate or at least try. Whatever answer you are getting, so don't bother about whether it is wrong or right, right? So in this class, no one is going to judge, right? Because yeah, you're not in right. So you can see that I did some mistake in calculation. So don't bother about. Okay. Yes. Okay. Yes, guys. Done.
Sir,
Yes.
I got the same answer.
Good. So three majority, right? Right. So yes, Akib, Amna. What did you guys get? Oh, one. And after this class, you guys will have one assessment. So yesterday you guys didn't take that, but yeah. But at 10:30, right? 10:30 is 8 p.m. case. So at 8 p.m. case, you guys will find some test activated in your account. So Faf, Rishita, and Akib already know about that. Enham and Amna. So yeah, you guys have your Learnivio account with you, right? Yes.
Sorry, sir.
Yeah, you guys have your Learnivio account, right?
Yes, sir.
So after this class, we have class assessment test. So whatever we have done so far in the class today, so there will be some question based on that, and yeah, there would be 5 questions to be precise, and the levels would be so first would be the easier one, and then the level will increase. So you guys please take that. So Rishita, Afaf, and Akib have taken those steps, so you guys also take them. Okay. So
Yes, sir.
at 8 p.m. KSA, you log into your Learnivio account and then you will find some class assessment section. So in that class assessment section, you will see some live test. And that would be about the average velocity, acceleration, and so on. Okay. Yeah, Akib and Amna, no answer so far. So you guys please try, right? So in the previous question, Amna tried, but oh, Amna is not getting, and so let us solve this question. So yeah, you guys are correct. Good, Afaf, Shita, and Anna, you guys are correct. So let me, because yeah, we can't deny the or negate the majority, right? So t by dt of 5t plus d by dt of 4t square plus, yeah,
Plus
yes,
d by dt of 3t plus d by dt of 5, which is constant.
yeah, this is 0 and 5 is outside, t cube is
dt
3,
cube by dt.
yeah. So let
plus
me write,
4
yeah,
dt square by dt
that's right. And
plus 3 dt by dt.
so then we'll have what? 15t square plus 8t plus 2.
Dt plus 3.
So this is the instantaneous velocity. And in the question, they have asked us to calculate the velocity at 2 seconds.
Second.
So this would be simply, we would be simply what? Why this is slow? Okay. So B is 50t square plus 8t plus 3. And B at 2 seconds would be simply 50 square plus 80 into 2 plus
79 meters per second square.
79.
Yes.
So this is 60 plus 16. So this is, yeah, 79 meter per second. So this is the velocity at 2 seconds. Right. Now the third question was the acceleration from 0 to 3 seconds. Right.
Yes.
So to calculate acceleration, we need velocity. And we have already calculated. So what do we know? We have already calculated what is V, right? V is, okay, let's wait for one more to just to activate this. Yeah, there is a technical glitch. So 15t square plus 8t plus 3. Right, this is the velocity that we know. So to calculate the average acceleration, we need to find out delta V by delta T. So V final minus V initial divided by T final minus T. So V final is V 3 second, V 0 second divided by 3 minus.
3
So
minus 6.
yeah, so V3 is 15 into 3 square plus 8 into 3 plus 3 minus of 3 divided by 3. So 3 cancel and we have 1. And 15 9, how much is 59? So that is 135. 135 plus 24 divided by. So 9, 5, 1. So 5 and so 53 meter per second square. This is the average acceleration. Okay, so you guys quickly note up to this point. Quickly note up to this point and then we'll calculate the instantaneous acceleration. So whenever you guys have completed, please tell me so that we can go ahead. Then, okay.
Sir,
Yes,
why we have write 3 two times?
this
3
one.
minus 3. Yes.
Oh, okay. So V3 is up to this point, right?
Yes, sir.
And now V0 would be how much? V0 would be 15 into 0 square and plus 8 into 0 plus 3. So you see that this part will cancel, this part will cancel. So we'll only have 3. So
Yes.
minus of V0 would give you minus, right?
Okay.
Okay, noted everything.
Sir.
Now the next question was acceleration and what second? So acceleration at 4 seconds. Okay, so let us calculate the acceleration at 4 seconds. And luckily, what we have calculated. So if the first two questions were not there, right? So if first two questions were not there, then we needed to find out this first, right? So we need to calculate the acceleration instantaneous, right? So for this, we use dv by. But we were given the x. So from x, we calculated dx by dt, which gave us, and we already have calculated this b. So now we know the form of b, then we can calculate this d by dt. So d by dt of 15t square plus 8t plus 6. Right. So I will directly do this problem. So we get what? 15 into 2t plus 8. Right. So this would be 30t plus 8. So this is the acceleration. Okay. This is the instantaneous acceleration. And they want us to calculate the acceleration at 4 seconds. Okay. So the acceleration at 4 seconds would be how much? 30 into 4 plus 8, which is 120 plus 8, which is 120 per second. So this is the acceleration. You guys please note it down, and then yeah. So then the physical quantities would be the
Done, sir.
acceleration. Done, already done. Yeah. What about rest of you guys? Yes.
1 minute, sir.
Okay. So you guys see that I directly used this velocity, right? Because I had already calculated this value. So then I didn't use this part, right? Because we already calculated. So I directly used this and then calculated the acceleration. So this was the point. Yeah. Any doubt up to this point?
Sir,
Yes.
we are taking TS2,
TS2.
T is equal to 2.
Yeah. So in this question 3, they wanted us to calculate. Yeah. So in this question, they wanted us to calculate. Find the acceleration at t equals to 4 seconds. So what is the time that is given?
Okay.
Yeah. So in the previous second question, t was 2. But for this question, t is understood.
Yes, sir.
Okay. Noted, everybody.
Yes, sir.
Yes.
Okay.
So one
Now.
second.
Oh. Okay.
Okay, sir. Thank you.
Okay. Done.
Yes, sir.
Okay. So now let me talk about. Okay. So what we have done so far in this motion in 1D. Motion in 1D, we understood about the frame of reference, right? So frame of reference, and from this frame of reference, you define two quantities: motion and rest, right? So if the body was moving, right? Then you defined the different attributes of the moving body, or different physical parameters, physical quantities that describe the motion of the body. So first was what? First was distance. Second was displacement. Third was speed. And fourth was velocity. And fifth was acceleration. Right. So in speed, we talked about three things. So speed was of two types. One was uniform, and then the other was non-uniform. So again, in non-uniform, we had two speed: average speed and instantaneous. Right. So again, for the velocity, this was the same diagram, and for acceleration, this was the same diagram. Right. And then we talked about all the things numerically, right? So we solved different kinds of question based on these concepts. Now the next topic is about when you have. So we understood about acceleration, right, guys? So what? How many types of acceleration did we had? Yeah. So how many types of acceleration we have?
Two.
Two, right? So there was two kinds of acceleration that we talked about. One was the uniform one, and the other one is the non-uniform. Okay. So now in the case of uniform one, we will talk about the equation that is related with this uniform accelerated, right? So uniform accelerated. Okay. So for uniform accelerated motion, we have a different equation of motion, right? So this you have already learned. So equation of motion. So first one is the, and I will write it in the vector form. So in vector form, this is V, which is U plus AT, right? Where this A is constant. So remember that we are talking about this equation of motion for only uniform accelerated motion. So uniform accelerated motion means that this A is constant, right? So in vector form, and then we have this S, right, which is for ut plus half a t square. Just remember that t is not a vector quantity. And then the last one is so we have the fourth one, but I will talk about this later. Dot v equal to dot plus a dot. So this is in the vector form, right? But we are talking about motion in 1D, right? We are talking about motion in 1D, so we can write this as V is equal to U plus AT, and S is equal to UT plus half AT square, and V square minus U square is 2A. So why? Because we are talking about motion in 1D. Okay, guys. Yes. Please write
Yes, sir.
this. Yeah, please write this part, and we can derive these three equations by two methods, right? So we can derive these three equations by two methods, and I will talk about both the methods.
Done, sir.
Oh, yes, guys. So, sorry, I got disconnected. Everybody is like, am I audible, guys?
Yes,
Yes,
sir.
sir, you're audible.
Who left? Okay, yeah. Thank you. Now I cannot. Okay, who is the host now? Who is the host? Yeah, I am. Sorry about. I got yeah, I was talking about this. These equations of motion, right? And we can derive these equations by two. So one is the graphical method, right? And the other one using the calculus. So do you guys remember the graphical method? Yeah, do you guys remember the graphical method that you did in the 10th standard? Do you guys remember that? Yes,
No, sir.
you guys have forgotten. Okay, so no worries. So how do we derive the equation? So derivation of right. So first is the graphical method, and the second one is the calculus method. So I have talked about the differentiation, but to Elham, Amna, and yeah, Abdul, I have not talked about integration, right? So in calculus, we will use this integration. So what I will do is that, uh, okay, so what I will do is that let me talk about this integration, right? So in differentiation, what we did, in differentiation, we had this function and we calculated this change from a very small change we calculated, this part, dy, right? So this was dy that we calculated, and this was dx, right, guys? And in integration, what we do is that we add up all these small values. So when we sum all these values, so this is called the integration. Okay, we have a very small change in y, and then we just sum all these integrations. So how do we write? We write as this. Okay, so this is what we call the integration. When we sum up all these smaller changes, right? And this is denoted by this sign. Okay, so we had okay. Let me talk about talk in this. So we had this differentiation, right? This was the differentiation, and
Yes,
yeah, and what we do is that, so we have addition, and what is the opposite of addition?
subtraction,
Subtraction, right? And we have multiplication. What is the opposite of multiplication?
division, division.
Division. So similarly, we have this differentiation, right? So the opposite of this differentiation is integration. Okay, so this is denoted by this, and this is denoted by this, right? So this is the differentiation with respect to x, and this is the differentiation with respect to integration with respect to x. So this is dy by dx, and this is y. Is this clear to you? Is this clear to you guys?
Yes, sir.
Okay. So similarly, we have
The integration would be integration f of x into dx, right?
It would be x into the x, meaning, what did you say?
Y equals to integration f of x into dx.
Yeah. So integration y would be, that is why I wrote y is fx, right? So I can write, and y is some function of, okay, let this, y. Yeah. Okay, so let this work and y this thing. Yeah, so I can write integration of y dx, and y is function of x. Okay, is this clear to you?
Yes, sir.
So okay, y. Hmm. Yeah, so okay, let's wait for some moment and let's see that. Working, but why? It's not. Okay, is my screen visible to you guys? Can you guys see my screen?
Sorry, sir.
Can you guys see my screen?
No, sir.
Okay, is this visible now?
Yes, sir.
So yeah, so now we have as similar to what we did in the differentiation. So we have some results for the integration, right? So, integration and integration of x n dx, right? Y is your x n. So integration of x n dn is how much? This is simply x n plus 1 divided by n. And there is some constant, but let us put it this constant, right? Or so this is the integration of algebraic one. And for the time being, we will only use this part, right? So did you guys see the difference between the differentiation and the integration? Differentiation is very small change, and integration is the accumulation of all these changes, right? So when you add all these all these small changes, then you get the integration. So integration is accumulation, differentiation is shorting it very out, so a very small change. Is this clear to you? Yeah, clear, guys.
Yes, sir.
Okay, so let us take an example, right? Let us take an example, and in that way, you can be able to understand. Why this is yeah. So integration of, let's say, x3 dx. Y is your x. So what would be the integration of x3? What would be the integration? So what is the power here? Yes. What is the power here?
Three.
3. So this would be x 3 plus 1 divided by 3 plus 1. So this would be x4 divided by 4 and plus 3. But let us forget this for now. Right. And can you guys tell me that what is the differentiation of integration of, let's say, 1 over x square? What is the integration of 1 over x square? You guys calculate and tell me the answer. Quickly calculate and tell me the answer. Yeah. What I will do is that I have a few minutes left, so I will take long. So y is 1 over x square. So what is the power of x? What is the power of x, guys? Yeah. Rishita, what is the power of x? Yes. What did you say, Rishita?
So, x raised to -2.
Minus 2. Correct, correct. So why are you hesitating? This is the correct answer. So now we want to calculate integration of minus 2. Okay. So this would be how much? X minus 2 plus 1 divided by minus 2 plus 1. So this would be x minus 1 divided by minus 1. So this is x minus 1 and minus, so minus 1 over x. So this is the integration of x to the power minus 2. Is this clear, guys? Clear? Yeah. Is this clear, guys? Okay. So
Yes, sir.
then, yeah, then we have two kinds of integral. So we have two kinds of integral. One is called the definite integral, right? So we have two kinds of integral. One is the indefinite one, and the other one is the definite. So you see that this is the integral, y, right? And it is equal to, so whenever you have this kind of integral, it is called the indefinite one. And the definite one is defined like a, b, and y. So you see that you have this upper thing and this lower thing. So these are called the lower limit and this is called the upper limit. Okay, guys. So if we have the limits of the integral, so this would be called a definite integral. And if we don't have a limit, so this would be called the indefinite integral. So is this clear?
Yes, sir.
So now what we will use? So in our question or in our purpose, we will use this definite integral. Okay, so let's say that we have a definite integral, right? Because the time is observable. So I will talk about this again, right? I rushed through this topic integration for Rishita and for Afaf. I have already done it.